Now when we started thinking about this, excuse me, I naively thought that if we add Suzumura consistency, maybe we can get close to having a closure operator for quasi-transitivity. But my co-authors very quickly disabused me of that confusion, and indeed it turns out it can be seen very quickly that this is not the case. That's the way it works. It's good to have young co-authors with fully functional brains. I highly recommend. Okay, what do we get instead? Well, we don't get the holy grail of the closure operator, but we get sort of a consolation prize. And what we get is that we can, if we add Suzumura consistency as a property, in addition to quasi-transitivity, we get the existence of what we call a minimal quasi-transitive extension. An extension of a relation is another relation that subsumes it and also subsumes the asymmetric part. Right? This is the notion of an extension goes back to a long time. There is a very well established result by Spinrite, and that shows that any transitive relation has an ordering extension, and variations of that result have been established by Arrow and by Hansen. What Kodro did in his 1976 paper was he suggested the use of Suzumura consistency as a weakening of transitivity, and he showed that Suzumura consistency is not only sufficient but also necessary for the existence of an ordering extension. So that's a very, I think, a very interesting result, not only in economics, but in social choice theory, but in mathematics. And unfortunately, in my opinion, it has been overlooked for a very long time. And part of the reason is that Kodro was a very humble and modest person. Right? The title of this paper is Remarks on the Theory of Collective Choice. And from that, I mean, you couldn't tell what rich results are in there. But again, that's the way Kodro was, and I'm not really surprised, because to me that's being humility and being modest is a sign of somebody being really good, because people who are really at the top of what they're doing, they also know how much there is out there that they don't know. So, thank you, Kodro. Anyway, so let's get started. So I'll start with some basic definitions and then move on to our specific problem that we're addressing. So we start out with a set of alternatives. We assume it's not empty. No other restrictions are required. No regularity conditions or anything. It could be finite, infinite, continuum, countable, you name it. We have a relation, binary relation defined on it, and we interpret it as usual as a goodness relation. Right? If you have a pair x and y in capital X, if this pair xy is in R, that means X is considered at least as good as Y. Once we have a relation, we can define its asymmetric part, we call it P of R, and we can translate it into the goodness framework. This could be a betterness relation. X is in this relation to Y, X is considered better than Y. And finally, we have equal goodness, which I denote by I. Now the notion of an extension, as I mentioned earlier, is that if we have two relations, R prime and R, we say that R prime is an extension of R if R is contained in R prime